Photoshop for free? Boy, there's got to be. That's it. Yeah, yeah. Okay. So dividing radicals. On to what the YouTube is supposed to be about. So, got to find a good example here. Oh, that's why I had the book opener there. All right. So dividing radicals is going to look. It's going to look like fractions. So let's do one. Let's do the square root of 12x to the fourth divided by the square root of 3x. Okay? So the easiest way to approach these is to simplify the fractions first. The square root of 12x to the fourth divided by the square root of 3x is the square root of 12x to the fourth over 3x. So, no, but now I can simplify. 12 over 3 is 4. What's x to the fourth over x? So, really all I'm finding is the square root of 4 times x to the third. So 4 is 2 times 2, so this is the square root of 2 times x times x times x. Let me pull off my pairs since it's a square root. So I got a pair of 2's there. Whoops. And so that gives me a 2 outside the radical. I can pull off a pair of x's to give me an x outside the radical. Left inside the radical is just an x, so I'll write it like that. So there's my division. Now, yeah, that's all for that one. That's simplified. Oh, there's more complicated. Of course there's more complicated. Okay, so let's do a cubed root. So we'll do a fairly simple cubed root. We'll do the cube root of negative 81 divided by the cube root of 3. So I'll do the same trick. I'll make that the cube root of negative 81 divided by 3. What's negative 81 divided by 3? Negative 27. So this is the cube root of negative 27. That one you might recognize as being negative 3. Or you might need to notice that 27 is 3 times 3 times 3. And then you got the negative. So the cube root is negative 3, whatever way you slice it. Don't need an I when we're talking about cube roots, only square roots. And we're not doing I anymore. So yeah. So we're only looking for real numbers. So if I got the square root of a negative number, we're just going to say no real answer, no real solution. Yes, ma'am. No, they'll end up staying separate. Good question. You need to divide by the same base of the root. Yeah. All right. So let's should we do a little harder cube root? All right. So one more. And then we'll get to the hard stuff. Cube root of 192x to the 8th power divided by the cube root of 3x. All right. So this is the cube root of 192x to the 8th divided by 3x. It's 192 divisible by 3? Yes, sir? Yes, it is. Do you know how you know 192 is divisible by 3 without checking? 9 plus 1 plus 2 is 12. And to check for divisibility by 3, you add the digits. If they are divisible by 3, then the number is divisible by 3. That also works for 9s. Yeah. If they add to any number that's divisible by 9, it's also divisible by 9. So it doesn't just have to be 9. It can be 18, it can be 27, it can be any of those. Yes, sir. Why do I do that second step? Because if I don't do that second step, it ends up taking me a few more steps. So it's best, in my mind, it takes the fewest steps for me if I simplify the fraction first, and then I try to find the cube root or the square root. It tends to simplify a lot faster. What's 192 divided by 3? Anybody got that one? 64. X to the 8th divided by x. All right, so let me try to simplify 64. 64 is 2 times 32. 32 is 2 times 16. 16 is, oh, I already see a perfect square in 16, is, oh, no, I'm looking for cubes. Whoa, sorry. No, I need to get that 2 in there. 16 is 2 times 8. I needed that one in there. 18 is 2 times 4. 4 is 2 times 2. What is the cube root of 64? Pair. Jeez. Sorry. What am I doing here? There we go. There you go. 3s. 2. What's the cube root of 64? 4. Now, x to the 7th. Yes. You want to change this problem to 3xy? Most certainly. Oh, but that comes to something we're going to do in a minute because we have to simplify it one more time. So not going to do it yet, sorry. Come on. So I get to pull out my triple and pull out the 2 from the radical, and there's another triple 2 from the radical. 2 times 2 is 4, or the cube root of 64 is 4. X to the 7th, I'll pull out 3 x's, and I'll have x to the 4th left. Pull out 3 x's, and have x to the 1st left. Can't pull out x to the 1st. So this is 4 times x squared times the cube root of x. Oh yeah, the cube root of 64, sure. It's the ones that don't simplify that you have to play the whole game with. Okay. So there, that one's simplified. Now we have to do what's called rationalizing the denominator. You did this in Algebra 1. Well, and so if I got the square root of 2 over the square root of 3, first thing I would do is put it all under one square root. Oh, the square root of 2/3 is not going to simplify. So now I'm going to back out and do the square root of 2 divided by the square root of 3. First I check if it's simplified, then I go back and I separate the fraction again. I cannot leave, I'm almost done, except I cannot leave the denominator of a fraction with a square root or a cube root with any kind of radical in it. The way I get rid of that radical is to multiply by, I take that square root of 3 and I multiply by the square root of 3. I'm squaring. That's what I'm doing. The reason I can multiply by the square root of 3 over the square root of 3 is that's the number 1. It's safe to multiply by the number 1. I have not changed the value of my fraction. Now what's going to happen? All right. I will multiply the square root of 2 times the square root of 3 and get the square root of, and then the square root of 3 times the square root of 3 is the square root of 9, better known as 3. So